Welcome to EDU World Space.
So in this video, we're going to work through question 88 from chapter 20, which says to draw Lewis structures for the AsCl4 plus and AsCl6 minus ions. What type of reaction, acid-base, oxidation reduction, or the like, is the following? So our reaction is 2AsCl5 reacting to form AsCl4 AsCl6, the ionic compound of our positive AsCl4 ion and our negative AsCl6 ion. So let's go ahead and start drawing Lewis structures. So for AsCl4 minus, we know that our arsenic is going to bring 5 electrons, and each of our chlorine atoms will bring 7 electrons, and then because we have a -1 charge, we have 1 extra electron. So total, we have 32 electrons. So to draw our Lewis structure, we can just go ahead and position our 4 chlorine atoms around our central arsenic atom, and then fill in the octet of each of our chlorine atoms, and that actually uses up all 32 of our electrons. And then we indicate the positive charge by putting the whole thing in brackets and putting a positive in the top right corner. And then I want to go ahead and assign oxidation states and formal charges while we're here. Now remember that when we're assigning formal charges, electrons that make up bonds are shared by that 2 atoms in the bond, but in oxidation states, the more electronegative atom of a bond will take all of the electrons in that bond. So let's start with oxidation states. So since chlorine is more electronegative than arsenic, it has its 6 lone pair electrons plus 2 that make up the bond. So we have 7 valence electrons minus 6 lone pair electrons minus 2 electrons in my bond. And that makes an oxidation state of -1. Now for our arsenic, we have 5 valence electrons minus no lone pair electrons and minus no bonding electrons because all of our bonds are with chlorine, which is more electronegative. So we have a +5 oxidation state. Now for formal charges, we have for chlorine 7 valence electrons minus 6 lone pair electrons minus half of the bonding electrons, so -1, and that gives us a formal charge of 0. Now for arsenic, we have 5 valence electrons minus half of our bonding electrons, -4, so that gives us a formal charge of +1. So let's do the same thing for AsCl6 minus. So we know that our arsenic brings 5 electrons and that each of our chlorides is going to bring 7 electrons. And then we have one extra electron because we have a -1 charge. So we have 5 plus 6 times 7 plus 1, that gives us a total of 48 electrons. And we can use all of those electrons by just positioning all 6 of our chlorine atoms around our arsenic atom and then single bonding them and filling in the octet on the chlorine atoms, and that should use up all 48 of your electrons. And then the whole thing has a -1 charge, so we put it in brackets and put a -1 to the top right. So assigning oxidation states, again, chlorine has 7 valence electrons minus 6 lone pair electrons minus 2 bonding electrons. That gives us an oxidation state of -1. And again, arsenic had 5 valence electrons and has no bonding electrons because it's less electronegative than chlorine. And no lone pair electrons. So the oxidation state on arsenic is +5. Now the formal charge for chlorine, we have 7 valence electrons minus 6 lone pair electrons minus half of my bonding electrons, so -1, which gives me a formal charge of 0. Arsenic, on the other hand, we have 5 valence electrons minus half of my bonding electrons, so -6, which gives me a -1 formal charge. So we have -1 for the formal charge on arsenic in this case. And we weren't asked for it, but let's go ahead and do the same thing for AsCl5. So we know our arsenic brings 5 electrons, our chlorine atoms bring 7 electrons, that gives us 40 electrons total. We can position all 5 chloride ions around our arsenic and go ahead and single bond them and fill in their octets, and that should use up all 40 of our electrons. The oxidation states on chlorine and arsenic are the same. You can determine those yourself and you'll see that they don't change. And the formal charges, on the other hand, so again, we have chlorine with 7 valence electrons, minus 6 electrons in my lone pairs, minus half of my bonding electrons, so minus 1. That gives me a formal charge of 0. Then we have arsenic with 5 valence electrons, minus no lone pair electrons, minus half of the electrons in my bonds, so minus 5. That gives me a formal charge of 0. So for our full reaction, we have the oxidation states are not changing. It's always plus 5 on arsenic and minus 1 on chlorine. So we know that this is not a redox reaction because for a redox reaction, we would see changes in oxidation states. Remember that reduction is a decreased oxidation state and oxidation is an increased oxidation state. So this is not a redox reaction. What about the formal charges? The formal charges on arsenic are changing. So it goes from 0 to plus 1 and 0 to minus 1. So that tells us that something is changing in this reaction. So while it's not an oxidation reduction reaction, it could be an acid-base reaction. So remember the Lewis definition of an acid and base. A Lewis acid is a molecule that donates electrons, and a Lewis base is a molecule that accepts electrons. So acids donate electrons, bases accept electrons. So how could this be an acid-base reaction? So we have our two AsCl5s reacting with each other, and to form AsCl4 plus and AsCl6 minus, what happens is this chlorine atom and the electrons making up its bond attack the other arsenic Cl5. So this is the lone pair, this is not the lone pair, sorry, this is these bonding electrons. These bonding electrons are the electron pair that is attacked. So AsCl5 both acts as the base and the acid. One molecule of AsCl5 is the base and the other one is the acid. So we have this acid-base reaction where electrons are donated from one AsCl5 to the other AsCl5.